So let us talk about how do we use the first derivative to find out the relative max or local mean. Relative means local, right? Local max or local mean. That's what we are going to do next. Now you see that, look at this one. The function is increasing here and then decreasing, right? If there is a combination of increasing and decreasing, then you see that there is a local max. If there is a combination of decreasing and then increasing, right, you can say like f prime is positive, f prime is negative. If there is a combination of first positive and then negative, then there is a local max. If there is f prime negative, it is decreasing, f prime positive, increasing. If there is a combination of negative and positive f prime, then there is a local mean. Look at this here, everything is increasing everywhere, right? On the left of C, it is f prime is positive, f prime positive, f prime positive. So there is no local mix or local mean or local max. And here f prime negative, f prime negative, right? So in this case also there is no local max or local mean. So what you can see here is, if the f prime changes sign from positive to negative, if f prime changes sign from positive to negative, then the function has local max. Okay, if f prime changes sign from negative to positive, then f has local max, local mean. Okay, so in these both cases, no local max or mean at x equals to c. So at x equals to c, at x equals to c, at x equals to c. This is what this the use says. Okay, let's look at this one. Let fx is continuous in an open interval containing c. If f prime of x changes sign, if the derivative of x changes sign from negative to positive, to at c, then f has local mean at x equals c. If f prime of x changes sign from positive to negative, and then negative, at x equals to c, then f has local max at x equals c. That's the first case. Okay, this is figure B, this is figure A. These are figure C and D. It is like A, B, C, D. If f prime of x, if the derivative of f have same sign on both sides, on the left side and right side, both sides of c, then fx has neither local max nor local mean at x equals to c. This is what we get. Okay, so let us do an example on how to use that concept. Let fx equals to 8 minus x times x plus 1 square. Okay, find critical numbers. How do I find the critical numbers? You find out the derivative and set that equals to 0, and or find out where the first derivative is not defined. How do I find out the derivative here? It is like f times g, right? How do you find the derivative of the product? It is f prime equals to, derivative of f is -1 times g is x plus 1 square, right? And then plus f is 8 minus x times the derivative of g. How do I find out? It is like u square, right? It's like, you can think this is like u and then 2. So it will be 2u, 2 minus 1 times u prime is 1. So basically you get negative x plus 1 square plus 8 minus x times, oh, let me write on 2 at the front. 2 8 minus x times x plus 1. This is what I got. Okay, now what you do is you need to simplify that one. Okay, if you simplify, what do you get? Basically you will get, if you simplify, you will get this. Can you factor out x plus 1 from both? Let me factor out that x plus 1. I took that x plus 1 out. What is left is negative x plus 1 and then plus 2 8 minus x. You see that? Let me simplify inside the parenthesis. X plus 1 is there, and there is a negative x minus 1 minus plus 16 minus 2x. You see that? So what do you get? You get x plus 1, right? And then negative x minus 2x is negative 3x. And then there is plus 15, right? Since there is no x in the denominator, or there is no no root, so the domain is all real numbers, right? So you can pick any, so you don't have to worry about where f is not defined. F prime is defined everywhere. F prime is defined everywhere, okay? So for the critical numbers, what you do, f prime equals to 0. This implies x plus 1 equals to 0. That is x equals to negative 1. This is one critical number, right? And then negative 3x plus 15 equals to 0. That is, what do you get? Negative 3x. Negative 3x equals to negative 15. I subtracted 15 from both sides. Now divide by negative 3. You will get x equals to 5. So the critical numbers are x equals to 5 and negative 1. These are the critical numbers, okay? So I want to find out where it is increasing and decreasing. For that, what we need to do is we need to draw a line, right? And mark those critical numbers. So how do I mark those? Is negative 1 is somewhere here. You see that? And then 5 is somewhere here. Now I want to pick the test points. So I want to pick a test point somewhere here, another test point here, another test point here. Let me pick negative 2 as a test point, and I will plug in the f prime. What is f prime? F prime is x plus 1 times negative 3x plus 15. F prime equals to x plus 1 times negative 3x plus 15, okay? And then I want to pick a test point here as 0, test point here as 6. Okay, let's plug in negative 2. What do you get? If you plug in negative 2 here, negative 2 plus 1 is negative 1, right? Times negative 3 times negative 2 is positive 6 plus 15 is 21 times negative 1. That's what you will get. So it will be negative. When you use negative 2, you will get negative sign. So it is decreasing here, right? It is decreasing here. Let's plug in 0. 0 plus 1 is 1, right? Negative 3 times 0 is 0 plus 15. So plus 1 times plus 15 is positive. So it is plus, 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 plus. You see that? And then here at 6, let's plug in 6. 6 plus 1 is 7 times. 6 times negative 3 is negative 18 plus 15 is negative 3 here. You'll get negative in the second times positive in the first. So it is negative. So what do you think about increasing and decreasing pattern here? I see this is decreasing, this is increasing, and this is decreasing in these pieces, right? So you can denote like that. So you can say that increasing in the interval negative 1 through 5, right? And then decreasing in the two intervals. What are the intervals? Negative infinity to negative 1. Left of negative 1, it is negative, negative, negative. So it is decreasing. And another interval is 5 through positive infinity. That is also decreasing interval. So tell me, how about the local max and local mean? Local max. Does it have local max? Yes. You see that? It is increasing. It is a combination of increasing and decreasing. So local max at x equals to 5, right? And how about the local mean? Local mean at x equals to negative 1. You see that? It is decreasing and then increasing. Combination of decreasing and increasing. Or you can say that f prime is changing sign from negative to positive at negative 1 and from positive to negative at 5. So that's why they have the local max and local mean. But if you want to find out the local max value and local mean value, how do I do that? I would write this way, okay? Value. To find out the value, plug in that 5 in the original question. Okay, what do you get? Let's plug in 5 here. 8 minus positive 5 is, 8 minus 5 is 3 times 5 plus 1 square is 6 square. 36 times 3 is 108, right? It will be 108. Okay, so if you want to write in a point form, it will be like 5 comma 108. You can write that way. You understand? Let's plug in -1. If I plug in -1 here in the original function, if you want to find the value, it is asking the height. Okay, so you need to plug into the original function. So 8 times -1 is 8. Sorry, 8 minus -1 will be 8 plus 1. That is 9 times. -1 plus 1 is 0. So 9 times 0 is 0. So value is y value basically equals to 0. So what is the point? -1 comma 0. If the point is asked, you can write that way. Okay. So I will do one more example. Okay, guys. Let us do this example. Find the increasing decreasing interval and then find local max or local min for this function. Okay. So what is the domain of this function? All real numbers except +3 and -3, right? So the function will not be continuous at +3 and -3. So it will not be differentiable at that point. So the critical points we will find out that later, but the critical points will be +3 and -3 and also some other critical points. Okay. So let us do that. So how do I find out the increasing decreasing? First find out the critical points. So to find out the critical points, you do find out f prime. Okay. Well, how do I find out f prime? It is like, you see that it is f over z. So f prime times z, x squared minus 9, minus f times g prime. Right? That's what you get. Divide by g squared, x squared minus 9 squared. Okay. So how much is the top? 2x cubed minus 18x minus 2x cubed. You see that? I'm just distributing that 2x. Divide by x squared minus 9 squared. Now, did you see that these are the plus and minus same thing? So what is left there is basically -18x over x squared minus 9 squared. Now, to find out the critical points, what you do is you find out where, for what value of x this f prime is 0, and for what value of x the f prime is not defined or infinity in the denominator. So the best idea is, what we do is you just set the numerator equals to 0 and denominator equals to 0 to find out the critical points. Okay, in that way it will be easier for you guys. Okay, so for critical points, critical numbers, I would say I do -18x equals to 0 divided by -18. What do you get? X equals to 0 is one critical point. Okay, and then solve the denominator as well. X squared minus 9 equals to, I mean, you can do square equals to 0, or and then take the square root on both sides. X squared minus 9 equals to 0, right? So what will be x squared is 9. So x will be plus minus 3. So the critical numbers are x equals to 0 and x equals to plus minus 3. So what do you do next after you find out the critical numbers? Because I want to find out the increasing and decreasing, right? So the next step is draw a number line and mark those critical numbers, right? -3, 0, +3, right? And then pick test points. I want to pick -4, I want to pick -1, I want to pick +1, I want to pick +4. What is f prime? F prime is -18x divided by x squared minus 9 to the square. You see that since there is a whole square on the denominator, whatever number you pick here, it will give you positive. So the denominator is always positive. Okay, for all these test points, denominator will be positive because there is a whole square. But the numerator, so the sign of f prime is determined by the sign of the numerator. Okay, so let's plug in -4. -18 times -4 is +72 divided by -4 square is +16 minus 9 is 7 square is positive. So the denominator is positive, numerator is positive. So it will be plus positive, right? So it means it is increasing. Let him plug in -1. -18 times -1 is +18 divided by -1 square is +1 minus 9 is -8 square is positive. So the denominator is positive, right? And the numerator will be positive as well. So plus. See? And how about a +1? -18 times 1 is -18 divided by, this is positive. So negative over positive will be negative. So this will go like this, decreasing, right? How about 4? Negative 18 times 4 is negative, divided by positive will be negative, negative, negative. So this is also decreasing. So what do you think? So it is increasing at, so increasing on where? Negative infinity to negative 3 and negative 3 to 0. We always take the open interval, right? Increasing and decreasing on 0 to 3 and then 3 to infinity, because all the right side will be negative there. So what do you think? The minimum or local mean or local max? Does it have local max? Yes, at 0 it has local max. See, you see there is a combination of positive and negative, increasing and decreasing. It is like that, right? So local max at x equals to 0. You see that? Local max at x equals to 0. And is there a local mean? No, because for the local mean you need decreasing and then increasing pattern, but there is no decreasing and increasing pattern together. Okay, there is no sign change from negative to positive. There is only sign change from positive to negative only. That's why local mean is not available. There is no local mean there. You see that? So you can draw the graph of this given function x square over x square minus 9, and you will see that there is no local mean. You understand that? So there is just the local max or the relative max only. Let us do last example for this section. Number B is, let's take fx equals to, let me take a function with some trig functions there. Okay, so let me do fx equals to 6 sine square x plus 6 sine x. Okay, we'll follow all the steps again. So first of all, we need to find the critical numbers. For the critical numbers, we need to find out the f prime. This is, you think like this is like 6 and then sine x square, because sine square x can be written like this, right? Plus 6 sine x, right? So do you think that this is like u square? So what is the, oh, this is not f prime, this is just f, right? This is just f. Now what do you think the f prime would be? So the f prime is equals to 6 times, it is u square, right? So 2u to the 2 minus 1 is just 1, you don't need to write, times u prime is cosine of x plus 6. What is the derivative of sine x? It is cosine of x. How do I simplify? Can you factor out something? Yes, I can take 6 cosine x out. If you take that out, what is left is 2 sine x minus 1. By the way, I forgot to write that the domain is between 0 and 2 pi. So we will be looking only between 0 and 2 pi here, okay? So what do you get? There is, so to find out the critical numbers, since these functions are defined everywhere, so you don't have to worry about where the f prime is undefined. Cosine is defined everywhere, sine is defined everywhere. So we are okay. So we will just do f prime equals to 0 implies either 6 cosine x equals to 0, that is x equals to, what do you get? If you divide both sides by 6, you will get arc cosine 0. What is the value of arc cosine 0? 1 is pi over 2, right? Because cosine pi over 2 is 0. So what is another? 3 pi over 2? And I don't want to go beyond that because that will be outside 0 to 2 pi. This is one set of critical value. You see that? To find out the other set of critical value, how do you do that? So basically you will do either this equals to 0 or that thing equals to 0, right? Or 2 sine x minus 1 equals to 0. So add 1 on both sides. 2 sine x equals to 1, right? So divide by 2, sine x equals to 1/2. So what is x? You need to take arc sine, right? Arc sine 1/2. So what are those values? X will be pi over 6 and then 5 pi over 6. So what are the critical values? There are many critical values there, right? So there is pi over 2, 3 pi over 2, pi over 6, 5 pi over 6. So now the next thing we do is we draw a line, number line, right? And then mark all those values. What is the smallest value? Pi over 6. And then the little bigger value is pi over 2. And then little bigger value is 5 pi over 6. And then the biggest one critical number is 3 pi over 2. Okay guys, so what you do is, it is easier if you use calculator. Okay, so let me write down what is f prime. What is f prime? F prime is basically 6 cosine x. Okay, 6 cosine x. So let me write down f prime, because we'll be finding the sine of f prime, right? So the f prime is 6 cosine of x times 2 sine x minus 1. Minus 1. Okay. So what I suggest you to do is, I suggest you to use calculator and then plug in test point here, plug in test point here, plug in test point here, test point here, and test point here, and then check the sign. Okay. So I want to pick a test point here as little smaller than pi over 6 will be pi over 7. That's my test point. And what is little bigger than pi over 6? I want to do pi over 5, right? If you decrease the denominator, the fraction will be bigger. If you increase the denominator, fraction will be smaller. Okay. What is little bigger than pi over 2? Just pi? Pi will be bigger than 5 pi over 6. So let's go this way. You want to do little bigger than pi over 2, okay? Or you can think little smaller than pi over 6, 5 pi over 6. Let's do 5 pi over 7. That way it will be easier. And little bigger than 5 pi over 6 will be pi, right? 5 pi over 5. Because if you decrease the denominator, you will get a little bigger number. 5 pi over 5 will be just pi. That's what I'm going to do. Okay guys, now what I do is I will plug in these values in my f prime and then plug in take the sign. Okay, so let me enter in the calculator. So you will get positive sign there, plus plus plus. You can basically plug in that pi. It is easier to plug in here, right? 6 times cosine pi is -1. 6 times -1 is -6 times 2 sine pi. Sine pi is 0. So that will be 0 minus 1 is -1. So -6 times -1 will be +6. So this will be positive. And then let me take, so 3 pi. This is, you can take, what is the big number bigger than 3 pi over 2? This is 2 pi. The last value you can pick is 2 pi. The last value on the left side you can pick it 0, right? Because that's what the question is giving, 0 to 2 pi. You are finding between 0 to pi. Let's find out a number little smaller than 2 pi, right? What is the number between 2 pi, 3 pi over 2 and then 2 pi? It will be 3 pi over 2, 7 pi over 4. Yes, because I am finding the average of those two, okay? 3 pi over 2 plus it is 4 pi over 2, right? So if you don't know how to pick the test point, you can take the average of those two bounds, okay? 7 pi over 2. So let me enter that 7 pi over 2 in my calculator for x. So it will be positive, okay? So sorry, it will be negative. So let me do that. Negative, negative, negative. So it is positive and then negative like this. Okay, so what do you see then? So increasing in the interval. Increasing in the interval pi over 6 to pi over 2, right? And then 5 pi over 6 to 3 pi over 2. That's the two increasing interval. And then decreasing interval is 0 to pi over 6. And then pi over 2 to 5 pi over 6. And then 3 pi over 2 to 2 pi, right? That's what you get. Now, how about the local max, local mean? Local max. So this is increasing and decreasing convention. So pi over 2, x equals to pi over 2, and then 3 pi over 2. Right? And here also increasing and decreasing. So local max, local max. Local mean is pi over 6 and 5 pi over 6. Local mean is x equals to pi over 6 and 5 pi over 6. Okay, so if you are asked to find out the point form, what you do is you'll plug in that pi over 2 in the question. Okay, so what is the question? Question is that, right? So if you want to write in the point form, this can be written as, this guy pi over 2 can be written as pi over 2 comma, if you plug in pi over 2 in the question, what do you get? 6 sine square pi over 2 is 1. 6 times 1 plus 6 times 1 is 12. Pi over 2, 12. And plug in 3 pi over 2. Okay. So what is 3 pi over 2 is, sine 3 pi over 2 is negative 1. Okay. So 6 times negative 1 is square is positive 6. And then 6 times negative 1 is negative 6. So 6 minus 6 will be 0. So it will be 3 pi over 2 comma 0. Similarly, plug in pi over 6. How much is that? 6 times sine pi over 6 is 1/2 square is 1/4. 6 times 1/4 plus 6 times 1/2. Okay, so that means 6 over 4, that is 3 over 2 plus 6 over 2. So 6 over 2 plus 3 over 2 is 9 over 2. So you can write like this, pi over 6 comma 9 over 2 comma. Similarly, you find out 5 pi over 6 comma, what is 5 pi over 6? So 5 pi over 6 is sine 5 pi over 6 is also 1 over 2, positive 1 over 2, right? So this is also 9 over 2. That's what you get. Okay, so if it is asked in the point form, xy form, you just plug in that into the original given question. Okay guys, thank you.